Hello, my name is Jamie, and today I want to talk about cqterrain, a library I wrote using cadquery and Python. The project is a library for modeling 3D printed terrain for wargaming. It's a collection of commonly used components. So here I'm on the README, the GitHub README. So I'm on the GitHub repo for cqterrain. And some highlighted features is we have project documentation, which covers all the various components. So tiles is one big area. So we look on here, this has a table of contents. It has a breakdown of the various tiles with images, and it'll have links for each one. It'll have a link to the source code for that particular object, the example, the usage, and then the generated STL for that example. There we go. And we have a change log, which is major changes between versions. So this is just a write-up of what's changed from one version to the next. It also has the list of dependencies for when you install it, some projects that are already using code from this particular library. So example, this pipe terrain set. This was made, printed using the cqterrain library, right? Instructions for installation, and then running examples off the library. As a demonstration, what I'm going to do is we're going to pick some documentation to poke at. Minibase. Yoink one of these guys. These should be a little bit easier, a little bit friendlier for me to run right off. So circle uneven. Yeah. So let's just grab this code, copy, Control A, Control V. And so we're going to bring from OCP, VS Code, import star, and hopefully this should run a little bit friendlier. So that's running it in VS Code. The nice thing with this is in this format, you can put a debugger on this. All right, but you can, put in print statements, do your debug, have other things happen. So like cq dot workplane xy dot box 10 by 10, if I can spell, by 10. And the idea is if we have show objects, and actually the VS Code library doesn't care. In this case, the OCP VS Code doesn't care if it's show object or show. And so we could say test equals this, put our code here, put that there, bam. All right. And then if I stop this guy and put a breakpoint here, and then run it in debug mode, in theory, it should stop someplace. Bam. Step forward, continue. Let's first thing. We'll go forward to the next one. It stops here. And okay, it's just showing everything in memory right now. So if I go down one, my base disappeared because I'm rendering this to the stack. When I go down to the next line, it went somewhere into NumPy. Okay. Back on my viewer, here it has the test and the show object. So we'll grab another example just for giggles. This guy. Yeah, let's grab this guy. Go back over here. Remove all this. Do the same exact thing. So from OCP VS Code, import star, and we should be able to just straight run this file. And you should be able to do that for any number of examples and be able to run it. And that's the whole intent of the library. And then, modify it to fit what you need, right? So instead of diameter 40, let's do a diameter of 80. We'll run it. And there's a base with an 80 millimeter diameter. And then that's running the OCP CAD viewer. If we run something else, let's do these guys. We'll grab this one. This should also work in CQ editor, right? In this case, these examples, you don't have to modify them to add any special import or anything. Let's see what this does. This should probably be slower than dirt. There we go. And that ran. So there we go. And again, this is kind of man behind the box a little bit. So I already have this library installed on a virtual environment. So that's how I'm just not having to do any special setup or installation. I was already prepared. The whole intent of these is that, yes, you can run these examples with editors in mind, but you could also put them in a Python code and run it as like a back-end process, right? So if we do cq.exporters.export, we'll do our exbase. We'll call this base.stl. And the thought is, if we run this, and I don't need it to be quite 80, let's do 32. Save our code. If we run this code, in theory, we should get this generate output from the show object, but we also should have gotten a generated base.stl relative to where we ran this code. So there's our STL file. And then the whole intent is that by going to this terrain demo, first off, let's modify base.py. If we take off the show object, so there's no output whatsoever, Control S. If we delete our STL, go to a command line, do work on install test. In this case, that's what my environment's called. If I run Python, what's the file? Test.py. This is where we start getting into the headless environment, right? You want to run it from some other subprocess or some other project or whatever. The code shouldn't care, right? It should be able to run in a batch type process. So the code ran, it had no output visible, but it created the base.stl. We can call this guy, open it. There we go. There's our file. Take it to your slicer of choice, slice it, print it, do the whole deal. Installation. So I'm going to go back to the README for cqterrain, install it how it's listed. So in this case, I'm going to do a pip install, point to the GitHub repo, and just install it directly. I'm going to go here, open a command line, and I'm going to mkvirtual virtual env terrain demo. Good enough? Good enough. So here it's saying I'm on this environment, but if I say pip freeze, and basically that comes back with nothing. What did that do? That should have worked. All right, let's do our right click. So we're gonna do pip install, dun dun dun, medication for all cqterrain, and hopefully that does something. So many ages later, hopefully this is installed. If I hit pip freeze, now the list is less empty, right? So this lists the base libraries that were installed. And so the idea is I should be able to go back to my test.py and see we took out the show objects. If I go here, and if I delete the base.stl, and if I run Python test.py, oh, let's fix that. So the libraries aren't installed for this current working one. So let's make it truly headless. Not the end of the world. Okay, and there's our generated output. to get this newly created project working with the viewer, if I hit Control-Shift-P, select my Python interpreter, and if I enter my interpreter path, and I'm going to go find it, in this case, it is in, not there, but in my home directory, envs, there should be terrain demo in here. I should be able to go to script, should be able to find Python, should be able to select my interpreter, and OCP CAD viewer should be able to work off of that. This guy, install libraries for cadquery. We're going to say yes. And effectively, this is setting up OCP VS Code, the plugin for that virtual environment, which is kind of cool. That's handy dandy. So this is showing like a true fresh kind of install setup, right? So this is running the wheel. I'm going to skip that for now because I already got my demo. So I should be able to bring this back, and we should be back in business. So I'll show my object. I'm going to comment out this guy, save it. So this is effectively from a fresh install. We went into the Python environment, set our interpreter, and basically reinstalled OCP VS Code for that given environment, which is cool. That's neat. I'm going to run this code. Maybe it'll work. Maybe it won't. Yeah, it did. So that's from a fresh install. And if I go over here and go to this guy, before we had a smallish list of things that were installed. If I do a pip freeze again, that list should look a little bit bigger, and it does. So the plugin, the VS Code plugin, installed some other stuff, but that's okay. That's cool. One other thing I wanted to note from the demo is that all of these example files and like the documentation, right? So if we go to book and stuff like that, if we grab a book, so all of these kind of initial variables I'm putting in here, right? They're already they already have default values. So like if we take this guy, rip everything out that we don't, but we're not customizing, right? If you look here in the default constructor for this guy, it's setting those initial values. So like this is like a bare minimum that I would actually need to run this, right? So if I save this guy out, run this guy, the result will probably look very similar. And the reason why I include all those parameters is so you can see what they are, see them in context, and then modify them. But like in your actual like code for your projects and stuff like that, you don't necessarily need all of these values, right? Like you can change out, leave the defaults in place you want, override the ones you don't want, and then just kind of go from there. Okay. And that's we'll do for the local installation. So I'm going to go over what is a developer install like. So this was previously I installed the application as if I was from a user standpoint, I was going to go to here, run this command and just install it from an environment. If I want to install it from a developer standpoint, you want to roll out your own features, you want to do a fork, you want to customize code. This is the demonstration for you. So I'm going to come to the repo. I'm going to copy the URL for the repo for cloning it. I'm going to go back to my demo project here, because why not? Type in CMD. I'm going to git clone, right-click, paste in what I need clone, paste it in. That's going to clone down the project. If I go into cqterrain now, so this is all of the files for the project. If I go into here, open a command line, work on our project is terrain demo at the moment, I think. Yep. If I do a pip install dot, this will do the installation as if we had done the previous one, but it's going to do it from local reference from this repo. Okay, so that installed the dependencies for the library. And now if I do a pip freeze, when we see the list, so all of these have versions attached to them. When we see like CQ more, it has a reference to the GitHub repo where it came from. Somewhere there's cadquery helper, that's the GitHub repo where it came from. In the case for cqterrain, this is the file reference from where it's coming from. So instead of coming off of a GitHub environment variable reference, it's now coming off of this local file reference. So now you can modify the files how you want, and effectively the code will be running as if it was from that environment. So if I go back to here, now where this code is referenced from should be in that local kind of context. So you see when I go to this guy, let's actually open our project manager. Open folder, desktop, terrain demo, CQ terrain. We'll open this guy. Sure, I guess. All right. So if I'm here and I'll go to my source code, terrain, mini base, and we'll go to say circle wood. Sure, why not? So this does stuff, right? So if I dump a print statement here, my custom print statement, all right, we put that in there. When we do that pip install, so like if I just run the code, it's not going to pick up this change. There's probably some things you could, some fancy stuff you could put in there to look for those changes and recompile. But right now, it's just not going to do that. If I take my test.py, paste this in here, does this reference? Yes, it does. So that's handy dandy. So that reference back to my local code. So one, now when I do the IntelliSense, it's going back to where I have this code locally installed. That's cool. And then if we look at this example, what is this doing? Maybe that's fine. If I run this code, what is it going to show down here? Cannot import. It's going to complain at me. Circle terrain mini base. Why not? What did I break? Cannot import. I broke something. Hold on a moment. Because I don't need to fuss with this in engrossing detail. All right, let's go back here. And knowing me in demos, I probably broke something. Pip freeze, pip test. What are you going to do? Of course, I need to rerun the code anyways, but let's just see if it runs. Hey, it ran. It did something. I'm not sure why OCP was blowing up on me there. Okay, so I don't care about that right at this moment. If I go back to this guy, and in this one in particular, where I ran the pip install, I don't care about you. If I go here and do pip install, that'll pick up my change for the print statement. Hold on a moment. So we're doing a pip install. We're going to install this guy locally. When I run this guy, before this was running fairly clean. When I run this guy again, in theory, yeah. So if I did this correctly, my custom print statement showed up. So I've now modified that source code. Okay, regardless, it ran, it generated the file, right? We can do custom modifications locally. We have reference to the documentation. The other thing this grants you when you start getting into this territory of that local install is the next thing I want to talk about is there is an example runner. So to run an example, you can run this straight example runner. or you can run the individual examples. And you got those when we download the library, right? So if I go here and say stairs.py, copy, and if I go here, base terrain demo in cqterrain, cmd, work on terrain demo. This has my pip installed for the library. I'm in the local reference. So now in Python, I'm going to go into example. I'm going to run stairs.py. And what that is, I'm going to go into example. I'm going to run, maybe that's the wrong reference. Let's go to stairs. I probably moved it on myself. Stairs, py. So let's fix that. Something like that. And I need to fix that in my README. So when we ran that, something's going to happen. And what I can do is I will take this STL, rename this guy to STL old. I'm going to create a new folder called STL. The whole intent is that when you run example runner.py, that runs all of the examples in the example library, right? So here I'm kicking off a single example, stairs.py, kick that off. So now if I go into my STL, there's my stairs.stl. And so that ran in a headless mode. And then we can look at it, see what it did there, right? And so if we want to run all of our examples, example runner, it's going to take a bit. If you are making changes to the library and you want to see if the examples still run, you have that available to you. Or if you want to add your own examples. And the important thing for me with that is for catching drift, right? So all of those STLs get dumped into version control, and then I run the example runner, and then if any of the STLs are majorly changed, right? If they pick up in the get change control editor, right, that they're a wildly different file, I can check those. I can spot check them to look for drift effectively to see if the implementation, some dependency of some dependency is modified this file and so this output in some regard. Okay, so that's the quick and short overview for. I'm getting barked at by a dog. That's the quick and short overview for cqterrain, and hopefully you have fun with it. I don't know, do something with it.